Let's do an example of finding arc length of polar equations. So if we have a polar equation, r is a function of theta, then we know that we actually have a special case of parametric equations. X is r cosine theta, y is r sine theta. So if theta is ranging between alpha and beta, then I could find the length of the polar curve, the arc length. Now, arc length, as we've seen for parametric equations, is given by an integral from alpha to beta, the start and end points, of dy d theta squared plus dx d theta squared. So that's how you would find arc length in general for a parametric equation. But in polar, we can use a trig identity to simplify just a little bit. So this is the integral from alpha to beta. Now, let me write this down. I could take the derivative dy d theta using the product rule. So using the product rule, the derivative would be r prime times sine theta plus r cosine theta. So that's squared. That's the derivative dy d theta. Dx d theta, again, using the product rule, would be r prime cosine theta minus r sine theta. So that's squared. So then you can expand everything out. You could do the algebra, you FOIL these two terms, you combine. I think what happens when you do the simplification is you get the integral from alpha to beta, the square root, and then you're going to get the derivative r prime squared times sine squared theta plus cosine squared theta. So I'm not showing you all of the algebra steps here. But if you FOIL everything out and you group every term that has an r prime in it, you would find sine squared and cosine squared. Well, you could kind of see that because if you square this first term, you get r prime squared sine squared. If you square the second term here, you get r prime squared cosine squared. Now, the cross terms actually cancel. Because I have a plus here and a minus here, the cross terms in the first parentheses cancel with those in the second. And you're only left with r prime cosine squared theta plus sine squared theta. So again, if you're not comfortable with this kind of a little bit of a leap in algebra, expand things out yourself, simplify. I think you'll definitely find what I have here. Now, we all know the trig identity sine squared plus cosine squared is equal to 1. So in the case of a polar equation, the arc length can be given by r prime squared plus r squared d theta. All right, let's do an example. Let's find the arc length of the polar equation. How about we do r is theta squared, and let's do theta in the interval from 0 to pi. First, maybe we should plot this to see what we're dealing with. So let's take a look at the plot. So if I'm at angle 0, if I'm at theta equals 0, I travel a distance away from 0 of 0. So there's theta equals 0. Let's see here. If I'm at pi over 4, so if I'm at a 45-degree angle, pi over 4, then r is pi over 4 squared. So I don't know, that's right here maybe. That's a distance r of pi over 4 squared. If I'm going straight up at pi over 2, if I'm going straight up at pi over 2, then I'm even further. So here's a height of pi over 2 squared. And as the angle theta increases, the distance away from the origin also increases. You're getting kind of like a spiral shape with this problem. So I'm going to try to draw a spiral. The farther that I go out depends on my angle. So that's just an approximate picture of what the graph would look like. This distance here would be a distance pi squared. So what's the arc length? What's the length of this spiral curve? That's the question. So the arc length is the integral from 0 to pi of the square root. So I have the derivative. The derivative would be 2 theta, I square that, plus theta squared. And I integrate with respect to theta. So now I turn this problem into a routine integration problem. So it's the integral from 0 to pi. I guess I get, this should be squared even. So then I get the square root of 4 theta squared plus theta to the 4th. I'm going to factor out a theta from the square root. So I get theta times the square root of 4 plus theta squared d theta. Well, now I could do a u substitution. So I'm going to do u equals 4 plus theta squared. Then du d theta would be 2 theta d theta. Employing my u substitution, whenever you do a u substitution, I really recommend changing the limits of integration. So if theta is equal to 0, then u is equal to 4. And if theta is equal to pi, then u is equal to 4 plus pi squared. I get an extra 1/2. So the theta d theta can be absorbed when I turn this into a du, but I also have an extra 1/2. So I'm going to have a 1/2 from the u substitution. Then I'm going to have the square root of u du. Okay, well, now you integrate and you're done with this problem. So I get 1/2. The integral of the square root function is 2/3 u to the 3/2 power. And I'm evaluating that at 4 and 4 plus pi squared. So if you'd like the final numerical answer, I think I get 1/3 4 plus pi squared to the 3/2 power minus 1/3 4 to the 3/2 power. That's the length of this polar curve. All right, great.